Our next panelist is Juan Luis Esteban at Benu Networks. Juan is VP of Solutions Architecture for Benu Networks, and in his career, he's worked with service providers of all sizes, and he's been an active contributor to standards groups with a deep experience in cloud-native solutions, broadband networking, Wi-Fi access, 5G convergence, and core network transport. And in his work with standards organizations and others, he's helped define several of the architectural changes that are redefining the industry today. So we welcome Juan and look forward to hearing your presentation. Go right ahead.
Thank you, Ken. Hopefully you can see the screen okay.
Perfect.
Okay, great. All right, so I will, okay, I'll move through this quickly, through the agenda. So I'll spend a few seconds just talking about us, about Benu, for people on the call who may not know who we are. So we were established in 2010. We're a heavily engineering-led organization with most of our employees. And we transitioned from hardware to software many years ago. So we started virtualizing network functions in 2015. And we've been involved in products like TWAG, WAG, CGNAT, SD-WAN products for business services, and BNG and the evolution to 5G. So we've been working for some time in this space. And, you know, we're here to talk about the choices that need to be made today around BNG and how that impacts the rollouts and deployments in WWC. So throughout the years, we've been deployed in multiple regions, so we've been deployed globally. And we work with a variety of partners, from infrastructure partners to software, NFVI partners, and switch fabric, and even public cloud partners. We run our SDH platform at scale and deploy it at scale with significant throughput running throughout these networks. So with that, we'll get into how does the landscape look for 5G and convergence. And really, we're seeing a explosion of different types of applications and innovation on the apps, but all of these need to work across 5G and fixed line. And that's really the challenge. When you look at the three pillars of 5G that we're all familiar with, the MMTC for massive machine type communications, or EMBB for enhanced mobile broadband, and ultra low latency services. That's been defined by 5G, but it also needs to work on the fixed line. And we're seeing, of course, new applications like explosion of remote workers, which need to be absorbed by the fixed line network, which is one of the reasons why we've seen the bandwidth growth in the past couple of years. But then, services related to IoT, to gaming, virtual reality, most of which are really pushing workloads out to the edge. And, that's really 5G, but it's also fixed line. So it's really finding the edge. It's really finding where do you terminate user plane traffic, and where do you break it out? And what's the latency that service needs to be guaranteed? So it's no longer about centralized architectures, and it's more about edge and services right there. So when we see 5G and convergence, and probably the stuff on the left is pretty clear to people, around 5G. So higher speeds, ultra low latency, ubiquitous rich, and massive network capacity that's driving new services, new revenue for different types of use cases. And then when we look at convergence, so how 5G and fixed line converge, some of the benefits are really, one of them clearly it's being able to run services from a common network. And that's where, the 5G slicing concept comes into play. So now we can drive slices from FNRGs and 5GRGs. FNRGs can be a VLAN based, it's a subscription, it's a PDU. You can run a slice from the FNRG, you can run a slice from the 5GRG based on the 5G encapsulation. And all of these things are managed by the NSSAI. and different DNNs can be selected for different applications. So, now we can envision use cases such as teleworker slices coming from the prem, from your 5G RGs, and those same teleworkers could be connecting from the 5G core on an eMBB slice coming into the same type of UPF node. So, we're at the point where in the industry with the standards from Broadband Forum, where we truly have a solution that integrates policy, services, and subscriber management in a 5G core. Whereas in the past, we of course had the ability to do things through the TWAG, through the EPDG into the core, but it was never a very tight integration. And we're now at that point that's very exciting where, the industry is transitioning to that situation. Obviously, the common core allows for simplified operations, for additional cost savings instead of having a split brain of your fixed line core and your 5G core, and then a unified customer experience. So there's multiple services that can be envisioned where customers may be on-prem or they may be on the 5G network, and a seamless service or unified experience can be provided. Right now, there's fixed line decisions that are being made. So there's massive fiber build-outs happening globally, and many of them associated to government funding. We're seeing old technologies being replaced by XGS-PON. We're also seeing convergence between cable labs and FTTH deployments. In that regard, we're also seeing cable labs and DOCSIS-based networks and fiber-based networks converging with unified subscriber management layers. So the BNG, in fact, becomes that unified subscriber management layer for any type of access. And we're seeing more applications driving higher traffic demands. So right now, there's multiple operators, small and large, making decisions about their next generation BNG and how that's going to impact the transition to 5G. So in this regard, Broadband Forum has done a great job paving the way to WWC. We had the 3GPP standards, and then of course, BBF started the work with TR459 and the disaggregation of the BNG. And then with TR456 with AGF, and further disaggregation of the AGF with WT458. So that's what we're seeing. We're seeing a common interface between control plane, user plane, and that's being leveraged for your BNG, your AGF, and then of course later with the combination of the UPF. So that's where Broadband Forum has been contributing significantly. Now we'll look at some of the key aspects that we think that operators need to have in mind when they select the BNG with the evolution to WWC in mind. One of the first things is thinking about flexibility and how today BNGs are deployed in a legacy monolithic BNG with fixed line chassis that typically has poor deployment economics, especially when you think about resilience or trying to move this chassis out to the edge. And the size and cost really dictates where you can place this chassis. Whereas if you move to a cloud native type of deployment, now your user planes, you have all the flexibility to make them large or small. Your edges may be different based on location. You would run this on off-the-shelf hardware, and there's different options also for your Kubernetes container layer. Plus, you can make these user planes available for different types of services or different types of slices. You could dedicate slices and resources on the user planes for different types of services. So that's one of the first things. The next thing is really how do you scale the network? So when you look at a classic BNG deployment, then you're really like growing in chunks. It's really difficult to scale up and down. We're seeing issues with blast radius with HA, and if you want to make that small, it's really difficult with monolithic BNGs. And where do you want to deploy? Sometimes we see hybrid architectures where you need to deploy in regional data centers, but also have edges and have user planes right at the edge. And we're seeing more and more of these edges being deployed. So really with a containerized and cloud native BNG approach, user planes can be sized properly. They can be scaled up, they can be scaled down, they can be scaled out to multiple user planes based on demand. Number three that I wanted to talk about is really the combination of the AGF and the UPF. You really need a solution that can combine the user planes, because we're seeing that this UPF for fixed line has different requirements in terms of bandwidth, in terms of functionality, in terms of scale, and where do you want to place the UPF. So there's clear benefits of combining the AGF, the user plane, with the UPF. And, there's going to be different interfaces. So there's going to be the 458 interface PFCP from user plane to AGF control plane. And then the UPF will talk to the SMF as it normally does. This is what it's called in WT458, the broadband UPF. And, the removal of the GDP tunnel between the AGF user plane and the UPF, there's benefits to that. And we definitely see the use case for a fixed line specific user plane function. The other thing is when we think about operations, we really need to think about fitting the platform into what's being deployed today for 5G cores. And we know that this is all based on, or most of it is based on cloud native solutions, whether it be on private clouds from the operator, or we're also seeing the trend of 5G core deployments on public cloud. So our solution fits perfectly into this new paradigm of cloud native architectures. In fact, we deploy in private clouds, and we're also certified with public cloud providers. And when this moves to, we see a transition or an evolution story where the BNG is cloud native, is containerized, it's deployed in the operator network in whatever telco cloud platform they may have selected. There's multiple options out there. And as that BNG or that solution is to migrate to WWC, we see the operator instantiating AGFs, whether it be adaptive mode AGFs, and then migrating some of the legacy RGs to that AGF function, and then bringing up 5G RGs, which would connect through the AGF. So we see an evolution path where your cloud native BNG has specific resources at the edge, and those resources can be repurposed for AGF instances. So now your BNG becomes an AGF that connects FNRGs, and in the future, it can connect your 5G RGs. And it's so easy to scale it up, down, and out with a cloud native architecture, and it's very difficult to do this with a chassis-based solution. And then the last thing I wanted to talk about is multi-access networks. And we're seeing this trend in the industry where the DOCSIS-based deployments, cable labs deployments, many of these operators are going to be deploying XGS-PON. They're going to have a hybrid network with DOCSIS access and XGS-PON. And they're thinking about, how do I deploy a unified subscriber management layer, where that's really your BNG, your virtual BNG today that evolves into your AGF plus UPF user plane. And now all the traffic coming from your remote MAC and PHYs, your OLTs, whether local or remote, that can be brought into this BNG, into this cloud edge, which has a unified control plane, which then exposes interfaces to AMF and SMF, and also open APIs to domain orchestrators and third-party OSS, BSS. With this in mind, the summary of the presentation is that we're seeing that these applications are becoming very network independent. So the fixed line network needs to be on par with 5G capabilities in terms of scale, latency, and the capabilities delivered by 5G are accelerating this trend. As operators are looking at selection of their next generation BNGs, they need to be aware that whatever they select today is going to be critical for them to deliver converged 5G services tomorrow. So they really need to invest in a future-proof, scalable and flexible disaggregated BNG that migrates into AGF plus UPF.